slide. So I want to thank Doug and Dennis for their leadership on this. My colleague, my friend, Dr. Martha Doerr of Nebraska will be the presenter next year. And these are links for past webinars and other important information that you should need. And as Doug said, questions at the end. Okay, so a presentation outline here, lots to go over. We're going to look at recent conditions, November and September, October, November, meteorological fall. Look at temperature and precipitation ranks on the state scale, but down to county level on precipitation. Then we'll look at the last 30 days to kind of give us an idea of where we are on the ground, and then speak about drought, since drought is impacting a good majority of our region. Then we'll look at final growing season progress. I won't dwell on those slides very much since we're over. Then we'll look at snow, fire, rivers, and lakes, all those components to our climate system. We'll look at impacts and notable events recently, and then kind of discuss what we've seen, important things across our states. And then finally, outlooks, looking at La Niña and the potential for a shift to ENSO neutral, and I'll explain that later. Short-term outlooks, and then finally, the winter season. So if we look at recent conditions, the first thing we'll look at is the state average temperature ranking for November. And the period of record here is 1895 to present. The darker the red, the warmer the state, rank-wise. The bluer the color, the colder the state. No records there, but we have a nice patriotic map of the United States with much of the East Coast and eastern part of the United States seeing above average temperatures through November, shifting to near normal across the central part of the United States, and then getting colder than average as we move towards the West Coast. Now, if we look at the statewide average temperature ranks for fall, September, October, and November, again, basically across much of the central region, the western part of the central region, above average temperatures through fall. And these above average temperatures, along with a drier pattern, helped increase drought conditions across the central region. Then you get into Iowa, Missouri, Illinois, the eastern Corn Belt, near normal temperatures. So the story here is warmer than average temperatures across much of the western part of the central region. Now, if we look at precipitation, to orient you here again, the greener the green, the wetter the month for the state. And when you see those brown colors, a below average month in terms of precipitation. Those white colors, again, are near average. So we look at the eastern Corn Belt, Illinois, Indiana, into Kentucky. We see drier than average conditions. We look at Iowa up into the Dakotas, Montana, near normal precipitation. We had several systems that came through that brought timely rainfalls. And then we get into Minnesota, Wisconsin, and seeing wetter than average conditions, kind of a split in the jet stream with a more active storm track over Minnesota and Wisconsin. Now, if we look at the fall precipitation rankings, what stands out to you here are the brown colors. Very dry conditions across basically all of the central region. If we're looking at the lower 48 as a whole, it was the 5th driest autumn in the last 6 decades. So very dry conditions. Looking at Nebraska, South Dakota, the 5th and the 9th driest fall season, with the period of record going back to 1895. Iowa, 15th driest. So overall, very dry conditions. We did see wetter conditions on the East Coast with some tropical systems, but overall dry for the central region. Now, if we look at this on the county level, so this is the same period of time, September, October, November, but we look at the county level to see if we're breaking any records or nearing any records. Wherever you see those darker browns, so western Iowa, eastern Nebraska, even into southern Minnesota, the Dakotas, and there's that one county in Colorado, much below average precipitation in fall. We look for fall for recharge after the vegetative demand has decreased. We were in a particularly dry fall, as the ranking showed on the previous map. So these fall conditions exacerbated drought conditions across the central region, and we'll get to those drought maps shortly. Now, if we look at the departure from normal temperature, so this is the actual average temperature that we see over the last 30 days, and then we subtract climatology, or the 30-year average. This is in degrees Fahrenheit. Wherever you see those green to colder colors, that's where we've seen below average temperatures. So basically across the entire central region, with pockets in Wisconsin and Illinois of slightly warmer than average temperatures, we've been cooler than average. And you look at the Dakotas and into Montana, anywhere from 6 to 10 degrees below average. So cool conditions this time of year, that does help in terms of drought when you have cooler conditions in the presence of drier conditions. If we look at the recent percent of normal precipitation, again, the accumulated precipitation, anything meteorologically made of water that falls from the sky, so liquid equivalent of snow, rain, sleet, all that. Wherever you see those warmer colors, that's where, as a percent basis, below average. So those darkest colors you see in western Kansas getting into Nebraska, and then pockets in Minnesota and the Dakotas, anywhere from 25 to below average percent of precipitation over the last 30 days. So again, a very dry stretch. The caveat here is we're getting into the driest part of the year, December, January, February. We're not, the expectation is not a lot of precipitation potential there. I will draw your attention to the northwest corner of Iowa, and we saw anywhere from 150 to 200% of normal precipitation just over the last 7 days, and that really helped in that D3, D4 category up in the northwest corner. Now, if we look at the percent of normal, that's okay, I confused myself. This is the actual, the 3-year departure from normal. The reason why I put this starting in 2019 is we really started ramping up drought conditions in 2020, May and June, in west central Iowa, and then stretching over into Nebraska. So this is a 2019 through the present day, the last 3 years. Wherever you see those warm colors, that's where we're below average. And these colors align well with the expansion of drought conditions over the last 3 years. You look towards Missouri and the mid-Atlantic states, wetter than normal conditions. And part of this is due to a more active tropical season in the Gulf and the Atlantic, pushing more moisture from landfall into these states while blocking off the moisture gate for the upper Midwest. And hence you see anywhere from 70 to 50% of normal in certain spots. Another way to look at moisture is soil moisture profiles. This is a NASA sport, remote sensed soil moisture from this time last year. This goes down to about 80 inches, so it gives us an idea of how much moisture is in the soil profile. Anywhere where you see, and this is on a percentile basis, so we think of a sponge, the 100th percentile would be a completely soaked sponge. Wherever you're seeing those oranges and reds, that's the 20th percentile or less. So you could think of that as 80% capacity within that soil profile for more moisture. So very dry conditions last year, pockets of near normal. Then we get through 2022 with drier than average conditions across much of the region, and we really see those precipitation, or the soil moisture percentiles explode, 5th to 2nd percentile. What these are showing across that band of western Iowa, and then even in the eastern Corn Belt, very dry soil conditions for this time of year. Luckily, we've had some recent rainfalls that have helped recharge over unfrozen soil profiles, so we've actually had infiltration of moisture, but we definitely need months and months of above average precipitation in these red areas to really put a chip in those soil profile deficits. Another way to look at this is the topsoil moisture, percent short to very short, and this is the week ending November 20th, 2022. Those darker browns are indicative of very dry topsoil conditions, and you can see that across much of the central region, with the exception of Wisconsin, which is at 18%. So overall, again, we're seeing a convergence of evidence that suggests very dry meteorological conditions and, as a proxy, soil conditions. Now we look at the drought map from last year at this time. We had the 8th wettest October in Iowa. We had very wet conditions across the central part of the central region. and that really helped alleviate D2 and D3 drought conditions, western Iowa, Minnesota, in Dakotas, and Nebraska. We had extensive drought across Montana, D3 and D4 drought. We go to this time. This is the most recent drought map released this morning and backdated to Tuesday. We see a shift in that D3 to D4 corridor further southeast. Now we're in Nebraska, a little pocket of D4 around Sioux City. Sioux City has a period of record going back to 1893. Still the driest year on record, and hence the D3 or D4 designation. So we've seen an expansion of the more pervasive drought categories, that D3 extreme to D4. So again, what the soil moistures are showing us, what the stream flows are showing us, so we definitely need a lot of precipitation to correct the current drought that we're seeing. Now, if we look at a 3-month class change map, this tells us the class, the amount of degradation or the amount of improvement. Wherever you see green on that map, that's where we've seen some improvement, 1 class to 2 class. But the overall story here are the warm colors, the yellows to darker oranges, 1, 2, 3 class category degradations over the last 3 months. And this is part and parcel, as I showed with the precipitation rankings in September, October, November, very dry conditions, coming off of a very dry summer, 29th driest summer for Iowa, in surrounding states also dry. So we're exacerbating those longer term precipitation deficits, and hence you see expansion even in the eastern Corn Belt in Illinois, Indiana, into Ohio. Okay, so we're gonna flip to our growing season progress, given that it's the last update from USDA since the last webinar. We look at corn and soybean progress. Basically, we're done across most of the central region, if not all of the central region. You see a lot of 97s to 100, and then you see those numbers, a lot of pluses below those. Those are the percent change from the 5-year average. So all of the states in the central region were ahead of schedule in terms of corn and bean harvest. Now, if we look at winter wheat conditions, we're really seeing percent good to excellent in Missouri, Illinois, Kansas, and Nebraska. But we've had lots of reports out there of windy conditions producing stand quality issues. So if we look at U.S. winter wheat conditions as an indice, with the index being a mixture of the excellent, good, fair, and poor added together, and all those years going back to 2004 on the top there, conditions are historically low. There was modest improvement in November with rain across the southern plains and then snow across the northern plains. However, this year's wheat condition index heading into dormancy is tied with 2012, again, another extensive drought year, for the worst of the 21st century, so the last 22 years. So you see that red line, that's 2022, an uptick in November, but still historically low for this time of year. And I thank Brad Rippey for these plots. Okay, shifting gears again, we're going to look at all of those things in the climate system that impact hydrology, meteorology. If we look at the current snowpack versus climatology, so that 30-year average, wherever you see colder colors here, those blues, that's where we're above average on snowpack. Below average band from Nebraska up through Wisconsin and Michigan, but it's good to see above average snowpack across the Dakotas and even over into Montana and Colorado, because this will lead to runoff in the spring that will help increase stream flows that are particularly low across the region. So overall, our highest snowpack above climatology is North Dakota, South Dakota, and into northern Nebraska. Now, if we look at the current snow water equivalent, we call this SWE, SWE, percent of normal within the basins that feed into the Missouri River. If you were to look at this plot last year, you would see lots of below average, lots of reds and oranges. We're actually doing quite well in the western United States, with snowpack anywhere from 74% of normal up to 120 in Montana and those western states. So this is good in terms of potential for melting and runoff and chipping away at those precipitation deficits, but also raising stream flows. But again, we're still early in the season, so we have a pretty good amount of time to go. Now, if we look at the snowpack water content within the Missouri River Basin, these are mountain snowpack. So this is a 2022 to 2023 comparison plot from recent high and low years. So you have that red line there is the 1991 to 2020 average. The blue shaded in on the bottom left of each of those plots is where we are now in terms of where we should be. The high year is the blue line, and the minimum year is the green line. So overall, the snow water equivalent is at 123% of normal above Fort Peck in Montana, and near the 1991 to 2020 average from Fort Peck to Garrison, North Dakota. So snow starting off well, but again, 95% accumulation period to go. So we'll just have to see how the large-scale behavior, if the La Niña hangs around, what that will do to impact our snowpack. But this is looking good so far as we are early in the season. If we look at the Missouri River system storage, so you think of all those reservoirs that we have on the lower and upper Mississippi, or Missouri, this is as of the 6th of December. System storage is 46 million acre feet, and that's below this 2013 minimum, that brown line you see there. I'll orient you with this plot. The 2011 there is a record year near maximum at the exclusive flood control level. And then you have the average there in the blue sliding scale, basically, of lines through the year, with July at peak there. 2022 is very low. The Gavin's Point release is currently at 13,000 cubic feet per second, and it's forecasted to reach, or it was forecasted to reach, 12,000 cubic feet per second on December 11th. Now, if we look at total runoff above Sioux City for September, October, and November, we're at 47%, 60%, and 51% of average. So well below average. If we look at fall in general, 53% of average. This goes to show you how dry the basin has been. Very dry conditions, no rainfall, no inputs into the streams, and hence we get lower levels in our reservoirs and along the system storage. If we look at 28-day average stream flow here, this are the USGS, the United States Geological Survey stream gauges across the basins in the United States. To orient you here, wherever you see green, that's near normal stream flows. So you think of the routing of water through our basins, that's a near normal level. And then you get into those darker colors, the oranges and reds, in Iowa, over into Indiana, and then into southern Kansas and western Nebraska. That's where we're below normal or much below normal. So inputs into those streams are very low for this time of year, and hence you see a lot of these basins below average. If you look at the hydrograph on the bottom right hand there, this gives you an idea at Baton Rouge, Louisiana, where the Mississippi empties out. This is in the context of hydroclimatology, so what we would expect this time of year. You see the black line there, that's the running average through the year, and as you can see in September, October, and November, that line falls below that red contour. That's showing you just how dry or how below average the Mississippi is. And this also helps explain why the Mississippi River tanked. Widespread drought over the last 2 to 3 years, and then very dry conditions in fall, along with elevated evapotranspiration, so an atmospheric demand, produced historically low flows this time of year. So you see an instant impact with that black line just kind of plummeting through July through fall. Now, if we, on the good news side here, if we look at significant wildland fire potential for December and then looking out through the winter time, we're not seeing a significant wildfire potential through the winter. And these would include maps that show January and February. Now, the flip side of that are there are several counties still in North Dakota that have burn bans or burn restrictions. So that also points to the dry conditions that we've seen. But if you were to look at this map last year, we did have some potential in the western part of the central region. If we look at Great Lakes water levels, all Great Lakes are running near their long-term averages or slightly below. They've dropped from higher levels in the previous several years, and forecasted levels over the next 6 months should remain near the long-term average. So that's what those lines, the squiggle lines, are the variability, and then you have the average conditions for the month in that green line. So the variable line, the blue and the black line, are running close to their average, slightly below, but this suggests near normal lake levels. Okay, now shifting gears again, we're going to look at impacts, statewide impacts from the weather that we've seen in November and over the fall, and also notable events. This first event I will draw your attention to because this was the bomb cyclone event last year, right now happening, December 15th, 2021. You can see this bomb cyclone forming in, or moving through Kansas and Nebraska, and I'll point you to this little notch here. It's a curiosity. It's called a hook jet. That's where it's actually, the pressure gradient is sucking in dust. That's those striations across Kansas, and it's transporting it along that cold front, which turned into a serial derecho and moved through Iowa. Iowa had 63 tornadoes over December 15th. Luckily, no fatalities from the tornado outbreak. One fatality from the serial derecho, but those 63 tornadoes were the highest tornado outbreak for December of any state. And that's not to mention the tornado outbreak that happened just several days before in Kentucky. So having 63 tornadoes after a widespread event in Kentucky was mind-boggling, but also it's Iowa's largest tornado outbreak on record for any month. So a pretty significant event. Again, lots of tornado and wind reports there. I mentioned again, serial derecho, one fatality in western Iowa because of a blown over semi, but a very interesting day last year at this time. Why I bring that up is we're currently going through a widespread system like that. Blizzard conditions in the Dakotas, severe weather across the Gulf Coast with 51 preliminary tornadoes reported, including New Orleans. This is the northern part of the goes east disk. So this is a satellite, visible satellite image last night of the cyclone going through the central part of the United States. So you can see where it's hooking around in the upper Midwest, and then convection forming along the cold front. And then I'll draw your attention out to the Atlantic, another potent low pressure system there that's kind of backing up the system. And hence, that's why we've seen this system just sluggishly move across the upper Midwest and through the Mid-Atlantic and Gulf states. So a slow moving system, blizzard conditions, as I mentioned, in the Dakotas, but we did receive beneficial moisture across much of the upper Midwest on unfrozen soil. So we did get infiltration from this event. So that was much welcomed across northern parts of Iowa and into Nebraska. All right, now we'll look at state impacts and how our weather conditions are impacting where we are statewide. Harvest generally completed without major delays or impact. In fact, as those plots showed you from USDA, we were ahead of the 5-year average for getting harvested. Dry and windy conditions, again, impacting winter wheat, stand quality, all those issues with winter wheat. We look at Montana and Wyoming. I showed you the snow water equivalent in the snowpack. Doing well right now, 85 to 100% of normal. Colorado also starting off with a beneficial snowpack, especially west of the Continental Divide. So we would really like to see an expansion, get above average snowpack across the basin to really impact those below average streams, rivers, and reservoirs. Late season above normal precipitation falling, again, with this current system and a system last week on unfrozen soils, getting the tank at least partially filled over parts of the region for the next growing season. We'll eventually freeze up, and with this freeze event that we'll see in the next few slides, we will freeze up, and any water that we get on top of that will just run off. No infiltration until we start to melt in late winter into spring. Another note, Minnesota, 10th wettest autumn on record. I thought that was apropos given how dry the rest of the region was, really helping them with their drought conditions across the northern 2/3 of the state. So it's very good to see at least some state is benefiting from above average precipitation. Other statewide impacts, I'll draw your attention to the map on the top left there. This is COCORAS, the Community Collaborative Rain, Hail, and Snow Network, civilian rain gauges across Minnesota, and I received this from my friends at the State Climatology Office. This, I believe, is accumulated precipitation, so liquid equivalent from this powerful fall storm that happened on the 8th through the 12th of November. It brought a myriad of modes of precipitation: rain, thunderstorms, very warm and moist air that translated into record humidities, strong wind, and a massive drop in temperature as the system moved through. Behind the system, some snow and heavy snow and ice. It was record-breaking as it arrived with more moisture potential than observed during November in Minnesota. So when we talk about moisture percentile or moisture, the amount of moisture in the atmosphere, precipitable water, the amount of water vapor that can be condensed out during a meteorological event. Records for that time of year, 23% above the previous record. So that's a lot of water vapor to work with. If we turn our attentions to our friends in North Dakota. A particularly dry fall across the state has led to concerns on spring forage production. And we've seen increased feed use due to cold weather, though there are no concerns or no major concerns on availability right now. But when we talk about dry conditions, we talk about our pastures able to rebound given timely rainfalls, and we haven't seen a rebound in those pastures across much of the central region, which is concerning as you move into wintertime, given that cattle feed off of surplus or supplies that are cut during the growing season. Okay, now we're going to finally shift gears into our climatological outlooks. We'll discuss La Niña a little bit, and then we'll look at the 7-day precipitation potential, the hazard outlooks going out through the next 7 to 10 days of potentially big cold snap for much of the United States. Then we'll look at the 8 to 14-day outlooks, and finally the seasonal outlooks for January, February, March, and February, March, April. First, to get us oriented here, we're in what's called La Niña. La Niña is a cold sea surface temperature anomaly in the tropical Pacific along the equator in that Niño 3.4 region that produces a stable high pressure system, so downward motion. When you have downward motion over the ocean and it's coupled to the atmosphere, we think of that as good weather, or you don't get convection or thunderstorms. But what happens is it shifts thunderstorm activity further west in the basin with upwelling warm water, and that impacts where the jet stream and the storm track sets up over the United States. The reason why this is interesting, it's the third consecutive winter of La Niña. We call it a triple dip or a triple stack. And going back to 1950, we only have 2 events like this. So pretty anomalous behavior. And if we look at the modeling for La Niña, it's likely to continue across the northern hemisphere through winter, for, December, January, February. And then we shift to equal chances of La Niña and ENSO neutral during January, February, March. ENSO neutral, we've all heard of La Niña, El Nino. ENSO neutral is right in between. So near normal sea surface temperature, temperatures in the Pacific, in the equatorial Pacific region. So if we do have a chance, and we do see a 71% chance of a transition to ENSO neutral in the February through April timeframe, what we're really putting out there is it's not a snap of the finger for a shift from La Niña to ENSO neutral. It will take the atmosphere to respond to the ocean and decouple, so the atmosphere won't respond anymore to the ocean, and that's when we're in the ENSO neutral phase of the larger scale oscillation. If we look at winter temperature patterns for the 20 strongest La Nina events since 1950, lots of variability. The blues are colder than average temperatures, the reds are warmer than average. If you averaged all these together, what you would see, as you do in 1949 to 50 or 64 to 65, when we do see La Nina years in winter, we have an elevated probability of colder than average temperatures across the upper Midwest into the Pacific Northwest, and then a higher probability of warmer conditions across the southern states. Remember that in your head. On the precipitation front, in terms of La Nina versus El Nino, highly variable where precipitation, we see above average precipitation. If we average all these years together since 1950 for La Nina, we typically see a bullseye of above average precipitation in the Ohio Valley into the Great Lakes, and then into the Pacific Northwest, and then drier conditions coupled with those warmer conditions across the southern states. Again, I'll just try to orient you here. I mentioned that cold sea surface temperature anomaly in the Pacific. The atmosphere responds to that and produces a downward motion. Meteorology is a study of equilibrium. So wherever you have downward motion, somewhere you have to have upward motion to equal out the atmosphere. And that's where we see a shift further west of those thunderstorms. That high pressure blocking in the Gulf of Alaska shifts the jet stream further north, and that dams the colder air further north. So that's where we see the upper Midwest into the Pacific Northwest with chances of colder temperatures. And then, as I mentioned, south of that jet stream, drier and warmer conditions with a wetter than normal bullseye in the Ohio Valley and Pacific Northwest. So if we look at the probability, and the probability here is on the vertical axis, and then the seasonal slice is on the horizontal axis. La Nina is the blue bar, ENSO neutral, again, near normal sea surface temperatures in gray, and then El Nino in that red bar. What we're seeing in the seasonal time slice is getting into January, February, March, and then February, March, April, as probabilities of La Nina decreasing as probabilities of ENSO neutral increasing. So we see in March, April, May time frame about even odds of La Nina to ENSO neutral. Then we get into April, May, June, and then further into summertime, higher probabilities of seeing that ENSO neutral phase, if we can call it a phase, near normal sea surface temperature anomalies. When we do see ENSO neutral, we have a good idea of analog years of La Nina and El Nino, but when we're in ENSO neutral, we fall back on recent trends, we fall back on climatology to kind of give us more robust guidance for La Nina conditions potential. Now, we often get asked, given that we're moving into the winter season, what is the potential for snowfall in La Nina? If we look at all analog years of La Nina and we take the average, wherever you see blue here, we have above average snowpack, or the potential for above average snowpack. And that's basically for our region, the Dakotas, Minnesota, Wisconsin, and then lower chances in western Nebraska and Kansas, and then over into Ohio. Now, I don't have the plot here for time's sake, but if we were to look at weak La Nina years, so a less cold sea surface temperature anomaly versus stronger La Nina years, in weaker La Nina years, we're slated to see above average snowpack across much of the upper Midwest, as opposed to strong La Nina years when we see less of a chance or below average snowpack. So we'll just have to see how this shakes out. For Iowa, we had a pretty decent snowpack in 2020. And then in 2021, we were below average by 10 inches. So again, these precipitation behaviors are highly variable and also impacted by other weather patterns and oscillations like the Arctic oscillation. Okay, final few slides here. This is the seven-day cumulative precipitation forecast. So this is a summation of what the forecast models are showing us for precipitation potential. Wherever you see that light green, that's 1/100th of an inch. So a dry signal across Missouri, Illinois, Indiana, over into Nebraska and Kansas. And then we start to see elevated probabilities of our elevated forecast of anywhere from 1/2 to 3/4 of an inch plus in Minnesota, eastern Dakotas, and over the Great Lakes. We see an active storm track in the Gulf of Mexico and on the Atlantic seaboard. So overall, looks like a generally drier pattern. Now, if we look at the 8 to 14 day outlooks, and we have a 6 to 10 day product and an 8 to 14 day product, and these are issued every day after about 2 p.m., 2:30. On the left is temperature, on the right is precipitation, and these are valid for December 22nd through the 28th. What we're seeing is the big blue bullseye, well below 80 to 90+ % chance of being below average for this time of year. Now, this is a broad swath of the eastern half of the United States, from the Dakotas down into the mid-Atlantic states. But what this is suggesting are temperatures anywhere from 10 to 15 degrees below normal, with colder pockets as well. And then we see ridging off the west coast, signaling somewhat of a transition. If we look at the precipitation outlook here, above average chances across the upper Midwest in Nebraska, near normal where you see that gray, and then a bullseye of below normal precipitation across the eastern Corn Belt, stretching into the desert Southwest. This goes hand in hand with the risk of hazardous temperature, again through that period, December 22nd through the 28th. Very high probability, especially within the December 22nd to December 25th timeframe. So this is an Arctic air outbreak that will come down through the United States. We'll see negative teens across the northern Rockies and northern plains, sub-zero temperatures reaching down into the central plains. So again, the timing on this is the 20th through the 26th for the coldest air. Take precautions here. We'll definitely see a freeze up of soil profiles, at least shallow, and cold air impacts. Finally, we'll look at the January outlooks that were just issued. Oh, this was not the updated one. Well, these were updated. We're seeing a similar monthly temperature and precipitation outlook here. And this is, again, the classic La Niña signature, where you have that cold air bullseye across the upper Midwest, and then generally elevated probabilities of warmer than average temperatures across the southern states. Then you look at the precipitation side, those two bullseyes I mentioned, along with drier conditions across the southern part of the central region. The rest of the region is what we call EC, or equal chance of above, below, or near average conditions. If we look at the January, February, March timeframe, again, temperature on the left, precipitation on the right. Again, that classic La Niña signature. A slight shift towards eastern Iowa for an elevated, wetter signal. But overall, this is what we would expect if we look at those analog years of La Niña into January, February, March. Then finally, we look at February, March, April. When we are in the modeling, we're starting to see a potential to shift from La Niña to ENSO neutral. We still have that La Niña signal within those lead to 90-day leads to February, March, April. So again, as the forecast models and the climate models start to ingest better data as we go through winter, we'll see perhaps a shift towards what our trends and recent climatology are showing us for early spring into summer. Finally, the seasonal drought outlook, and this is valid December 15th through March 31st. Basically, wherever you see brown on here, that's where we see drought persisting, or conditions within the climate models are not suggesting an overly wet signal, and hence drought persists. Where we are seeing improvement are across the northern stretches of the central region, and then from eastern Iowa all the way over into the eastern Corn Belt, the potential for drought removal or drought improvement. So the longer term climate models and numerical models are suggesting a potential for wetter conditions. Finally, the outlook summary here, short-term outlook, so showing high probabilities of a very anomalous cold air outbreak from the Arctic and near normal precipitation potential. The La Nina signal persists through winter 2022-23. Widespread precipitation variability in that wintertime La Nina signal. Dominant behavior in precipitation shifting slightly west into the Midwest. And again, the strength of La Nina will be a good indicator of the snowpack potential. Higher potential for a transition to ENSO neutral as we get into early to late spring. But again, this won't be a snap of the finger or a flip of the switch. It'll take several weeks for the ocean and the atmosphere to respond. And climatology in recent trends will then provide us better guidance as opposed to having an El Nino or a La Nina phase around. Finally, potential drought improvement across the upper Midwest through the eastern Corn Belt. Here are further information on our partners. You can find previous recorded presentations and also all kinds of information on outlooks, recent reports, state climatologists, the regional climate centers. All of your links are right here. We'll take questions, and thank you very much for being a captive audience.
Hey, Justin. Thank you.
Yes, sir. Thank you.
Could you go back to that last slide? We need to. No, not that one. The one after that. Oh, we need to change. Maybe we can change these on the fly. We need to change the location of the RCC. So while you're doing that, well, we will. So there's some faulty information on there. It's a little timed out. It's changed a few things. Not so much that one, but just a link to where the Midwestern Regional Climate Center is.
Yeah.
Yeah, just change it to the Purdue one if you don't mind, if you have time. And that's also, yeah, it's actually on the one before this slide because we have Illinois in there. So anyway, we'll fix those. We'll get them on the slides. So if you go to the correct places, that's where you can go to if you want to see this presentation or share it with somebody. We'll have that corrected. In terms of questions and comments, we have a couple different things. Are the expected cold temperatures over the next 14 days a sign of a polar vortex? Well, what it's really a sign of, rather than a polar vortex or a what do we call that? Stratus. Can't say the word now. Help me. Stratospheric warming. It's really a blocking system where, as Justin mentioned, there is some blocking. Blocking basically means the atmosphere slows way down and things don't move as fast as they should, and cold air goes south, warm air goes north in different parts of the globe. So this looks like it's going to change by the end of the month, but until the end of the month, we look to be locked into this cold air sort of outbreak. That I'm getting an echo here, Justin. That Justin had on the forecast there. So, is La Nina still the dominant teleconnection? You know what? It isn't. AO, the Arctic Oscillation, is the dominant one at the moment, and that's another reason why we're seeing so much cold air. However, La Nina and AO, when they team up, if you will, cause these cold air outbreaks. And in La Nina years, we tend to see more cold outbreaks than we do in El Nino years. So in a way, it's the dominant long-term seasonal, and the AO is the short-term dominant teleconnection. There's all sorts of periodic teleconnections that kick in, if you will, at different times, and so that's what we're seeing right now in terms of sort of several cold systems, if you will, influencing North America.
Doug, and to quickly add on top of that, the reason we don't talk about the Arctic Oscillation very much is it is influential, but it's very difficult to forecast more than at best a few weeks ahead. So it's not something we can look at on a seasonal basis and give you much guidance. La Nina can give you more of a guidance on a seasonal basis.
Yep. And like I said, and I think Dennis would agree, and Justin would agree that when those things sort of coalesce together, that's when you get some pretty good cold temperatures down into North America somewhere, into the U.S. anyway.
Amplified outbreak.
Yep. Yeah, a lot of, so someone was mentioning, thank you, Gene, that we're seeing a lot of very, pretty good standard deviations of negative AO at the moment. And that just means a strong signal from the Arctic Oscillation. We could probably explain that at a different, show that on a map. It's probably easier to show it on a map than to try to explain what it is. But it basically allows cold air from the Arctic to spill south. What climate trends could be expected? Could be expected in a switch. What climate trends should be expected in a switch from La Nina to neutral? Yeah, go ahead, Dennis or Justin, explain that. Because it's not easy. It's not easy to say what neutral will be. La Nina is sort of an amplified neutral in a way. I don't know, Dennis, do you want to say anything about neutral conditions?
Well, okay, neutral conditions means we don't have an El Nino or La Nina influencing us. So we don't have that influence or that guidance to bank on. The other part is this looks like it's going to fade. I think Justin mentioned late winter into early spring. So there's a shift in the patterns that we would expect anyway. And then we don't have El Nino or La Nina. So the potential for what can happen becomes much broader. So we start looking at things like trends. What are the more recent trends at different times of the year? Wet springs is something that we've seen overall, despite what we have in the last couple of years. So the trends for wetter springs would be an advantage to us at this point. Usually we don't quite want wetter springs. And then looking at computer models too, what computer models tell us. So expect the additional outlooks not to be as specific going ahead because we don't have as good a guidance during neutral conditions. Justin, do you have anything else you want to add to that?
Yeah, lots of EC on the map. Now I didn't include these maps, but I did do a composite of years since 2000 of a La Nina transition into ENSO neutral from late winter into spring. And again, it does on the temperature side look like chances of colder than average temperatures across the upper Midwest. And then the potential for wetter conditions, not exceedingly wet, but wetter conditions as Dennis kind of outlined with recent spring trends from eastern Iowa through the eastern Corn Belt.
Yep, and those trends can be long term, and I don't know if Justin, you have because I'm getting a lot of echo from somebody. If you're on the phone and on the computer, okay, that makes a difference. Anyway, those trends can be influenced locally. There can be local as well as regional, and of course, sort of hemispheric wide trends that all can play a part later in the summer. If you have a wet early in the spring. If you're wet early in the spring and that carries into summer, you can have amplified precipitation, for example, and things like that. Those are more local and regional. But again, dry land, on the other hand, or dry conditions can lead to less precipitation later in the year as well. So there is a concern, and maybe you should go back to, why don't you go back to slide 47, Justin, just to give a flavor of what. Yeah, right there. So if you look at February, March, and April, you see that, if you will, sort of dry tongue or lower probabilities of precipitation on the right map, sneaking back up into Kansas and Nebraska and such. That's indicative of a typical La Nina signal. We don't want to see that. We don't want our spring, if you will, to get off to a dry start like that, especially in the area that's already in trouble, right? So it's worth watching and something to take into account. Another question was, how deep is the frost depth? Is there any hope I'm sorry. How deep is the frost depth? Is there any hope the frost will melt and provide moisture? So, Dennis, why don't you, or either one of you guys, because you both deal with that issue and that question quite a bit in the ag world.
I just pulled up, I looked at some of the frost depth maps, and frost depth is quite variable. Basically, from parts of Nebraska northward in the plains, we have a frost depth of at least 6 inches. Some places it's close to 2 feet already, probably places where there's not snow on the ground. As you go over into Minnesota and Wisconsin, we have frost depths that are minimal to maybe 10 inches in places. We have some snow over there, and snow is an insulator. So it doesn't allow the frost depth to develop quite as deep until we get a lot of cold coming on. So the frost depths are not crazy deep. What's something we'll have to watch in the plains where we don't have as much snow, especially with the additional cold coming on. The very dry soils are going to allow these frost depths to take a pretty good dive, I would expect, in the places where there's not snow.
And here's maybe $1 trillion question. What's the reason for a triple dip of La Niña? Is it more likely than a triple dip of El Nino? I think I know the answer to the second one more than the first one, but I think the answer to is it more likely than a triple dip of El Nino? I'd say yes. That's sort of rule of thumbish rather than I have scientific proof to. Well, I don't know how many triple dips of El Nino we've ever had, maybe none. The reason for it, that's a great question. Some people will debate that is a signature of climate change, and some won't, I suppose. Anybody else want to comment on that? The luck of the draw. So
I can't add any additional. Yeah.
Yeah, we don't know. I'd say that since it's so rare that the jury's out on why or how that happens. It's just, it gets locked in and it's sustained. 2 years in a row isn't that uncommon. How many times that's happened, but it's not that uncommon. 3 in a row, like we said, they've only had, this is the third one since 1950. So, and anything? Go ahead.
Oh, sorry. To answer that question, you would need a good data set of those triple dips to then look at the large-scale dynamics in the atmosphere to kind of flesh out any kind of behavior that would cause upwelling of colder air or colder water. But yeah, with 3 on record, it's hard to dissect that behavior.
Yep. And Dennis or Justin, do you want to say a little bit more about, we're having this huge storm. It's dumping literally feet in some places. Of course, it's blowing off because we're having winds of 40 and 50 miles an hour, gusts, I should say. Any comment on sort of what we need to see to lower the risk, if you will, for water supply, for all kinds of sectors next spring? From here through, let's just say, from here to March at least. We'll just kind of excuse what normally happens in April, May, and June in terms of a wetter time of year. But if we start seeing mud on the ground, should we be like, oh, the drought's over, we don't need to worry anymore? If we see streams come up a little bit, do we need to think, oh, we don't need to worry about that? Drought's done. We'll worry about it when we get into June or July next year like we normally do.
No, I mean, we're going to need several months, if not more than a year, of above average precipitation in those drier parts of the central region. And for my expertise, Western Iowa, you look at Sioux City, around there, 47% of normal precipitation for the year. Going back 3 years, 25 inches below average plus in certain parts of the state. So you really have to get a lot of water into the soil profile to replenish those stocks, but also wetter soils, you'll get more runoff into the stream. So you'll see a rebound in those stream flows as well. So we're going to need in those D3 and D4 regions a lot of precipitation to put a dent in those longer term deficits.
I'll piggyback on what Justin talked about, reinforcing especially that example area of northwestern Iowa. ISU Extension has a couple folks that go out and they actually take soil samples and measure the amount of moisture in it. For comparison, a 5-foot profile there can hold up to about 11 or 12 inches of water. Average for this time of year, for what we've seen, would be around 6 or 7 inches. They took some samples that had less than an inch, around a ½ inch of water in them. So we would need, in this case, 5 to 6 inches of water right now to get back up to average in the soil for this time of year. Plus, we would need more on top of that. So we've come nowhere near that. Is the additional moisture helpful? You bet. Does it solve the problem? No way. So
absolutely. And then just the final note there is we talk about wintertime snowpack. What is the snow water equivalent out of a snowpack? Well, generally 8 inches, 10 inches, 12 inches of snow, 1 inch of water. So you're not getting a lot of water out of that snowpack, number one. But if the drier soils are frozen deeper, it's going to take a while for those profiles to thaw late winter, early spring. So even if you're melting that snowpack, a lot of that's not infiltrating, it's running off, and you're not getting the rebound that you need, as Dennis said, of replenishing those profiles.
All right. Hey, thanks. It's a little past 2, and I really appreciate all of you who've stuck around this long. If you have any other questions or comments, hopefully you know how to reach us if it pertains to something you need today or whatever. Happy holidays to everyone. Thank you very much again, Justin, for the presentation. And thank you, Dennis, for getting on after your trip at the end. And we will see you next year on the 20th of January for the next one of these. Hopefully we'll know a little bit more about what's going on with La Niña and such. So again, happy holidays. Have a restful vacation if you get one. Thank you all.